This last transformation that we're going to talk about is called a dilation, and a dilation is a transformation which makes our figure bigger or smaller with respect to the point called the center of dilation. Now, for our purposes, the center of dilation is always going to be the origin in these problems. And the last vocab word we need to know there is a scale factor. Our scale factor tells us how much larger or how much smaller our figure is going to be when we perform the dilation. So we'll get into that a little bit more. But for now, let's go ahead and look at example number 1 here. And let's take a look at how we can perform a dilation on a figure in a coordinate plane. So our instructions say draw the figure with the given coordinates, which I've already done for us to save a little time here, and then dilate that figure with respect to the origin on the coordinate plane. And lastly, we want to give the coordinates of the image. So number 1 here, if we zoom in, they give us the coordinates for A, B, and C. A is 1, 1, B is negative 2, 3, and C is negative 5, negative 4. And they tell us that our scale factor is equal to 2, or K is equal to 2 here. So our first step would be to go ahead and graph those points and create that figure, which I've already done for you. So now we can jump right into finding the coordinates of A prime, B prime, and C prime. So to find the coordinates of A prime, we're going to take the point A, which is 1, 1, and our scale factor, and we're going to multiply each of our coordinates by our scale factor. So when we're performing a dilation, we are going to multiply by a scale factor. So if A is 1, 1, if we multiply 1 times 1, that gives us 2. And 1 times 1 gives us 2 as well. So A prime is going to be the point 2, 2. Same thing for B prime. We're going to multiply the x coordinate by 2 and the y coordinate by 2. So negative 2 times 2 is a negative 4. And 3 times 2 is 6. So we have the point negative 4, 6 for our B prime. And for C prime, if we multiply negative 5 times 2, we get negative 10. And negative 4 times 2 is negative 8. So now we can go ahead and plot those points here. A prime is 2, 2. B prime is negative 4, 6. So that's going to be up here, negative 4, 6. And C prime is going to be negative 10, negative 8 down in that third quadrant. Okay, we go ahead and connect the dots. I would recommend using a ruler here when you connect the dots. I can't really do that on the touch screen, but you get the idea. We have that enlarged image there of A prime, B prime, and C prime. Okay. We're going to do the same steps here on number 2. So number 2, we have the triangle EFG, and we are going to dilate it by a scale factor of 3. So that means we're taking all of our points and multiplying them by 3. So let's start with E. If we multiply 1 by 3, all right, we're going to multiply by 3. 1 times 3 is 3. 0 times 3 is 0. So E prime is the point 3, 0. For F prime, if we multiply those both those coordinates by 3, 0 times 3 is 0. 3 times 3 is 9. So we get the coordinates 0, 9 for F prime. And for G prime, if we multiply the coordinates of G by 3, we should end up with negative 6, negative 6. So let's go ahead and make those points on our graph. E prime is 3, 0. F prime is 0, 9, so that's all the way up here. And G prime, negative 6 down in our third quadrant. And I would recommend, once again, use a ruler to connect your dots to create your image and your figure. But you get the idea there that we have an enlarged image of our original figure. Okay. A couple more examples here. Example 3, we are given the quadrilateral ABCD, and we want to dilate it by a scale factor of 1/2. So that means we are going through and multiplying all of our coordinates by 1/2. Well, multiplying by 1/2 is the same as dividing by 2. So we can kind of do this math in our head. 6 times 1/2, or 6 divided by 2, is 3. 4 times 1/2, or 4 divided by 2, is 2. So the coordinates of A prime there are 3, 2. For B prime, if we divide both those by 2, we're going to end up with 4, 0. 8 divided by 2, or 8 times 1/2 is equal to 4. And 0 times 1/2 is equal to 0. For C prime, if we multiply both these by 1/2, we should end up with 2 times 1/2, or 2 divided by 2 is equal to 1. 4 divided by 2 is equal to 2. We end up with the coordinates 1, 2. And for D prime, 0 times 1/2 and 0 times 1/2 both remain 0. So there are our image coordinates. So let's go ahead and plot those. There's D prime. A prime is 3, 2. B prime is going to be 4, 0. And C prime is 1, 2. There you can see we have an image which is smaller than our original figure, but that's still a dilation. Remember, dilations can make our images bigger or smaller. And we'll talk about a little bit more about that in depth here after we finish example 4. So example 4, we have a quadrilateral EFGH, and we are dilating it by a scale factor of 0.25. Now we could go ahead and multiply all these by 0.25, but to make life a little bit easier on us, 0.25 as a fraction is the same as 1/4. So let's just use this k is equal to 1/4 in our head, and it'll make life a little bit easier on us. So for number 4, let's start with E. To find E prime, we're going to multiply both of those by 1/4. Now multiplying by 1/4 is the same as dividing by 4. So -8 divided by 4, or times 1/4, is -2. So we're going to get the point -2, -2. If we multiply the points of F, the coordinates of F, by 1/4, we are going to end up with F prime, and 0 times 1/4 is going to be 0 for both of those coordinates. So we're looking at the point 0, 0 for F prime. For G prime, if we multiply the coordinates of G by 1/4, 8 times 1/4, or 8 divided by 4, is equal to 2. And -8 divided by 4 is going to equal -2. So we're looking at the points 2, -2. And for H, if we multiply the coordinates of H by 1/4, we should end up with a 0 and a -1. So let's go ahead and create that image there. So F prime, it's right there. E prime is -2, -2. G prime would be 2, -2. And H prime is 0, -1. We end up with that image which is smaller than our original figure. So it's the same shape, just smaller than our original figure here. So one thing that you should have noticed here is with regards to scale factor, if we are multiplying, or if our scale factor is greater than 1, so like in examples 1 and 2, our scale factor was greater than 1, our image gets larger than our original figure. Down here in examples 3 and 4, we had scale factors that were less than 1, right? We had a scale factor of 1/2 and a scale factor of 1/4. Whenever the scale factor is less than 1, okay, that is going to make our image smaller. It's what we call a reduction. So our image gets smaller as compared to our original figure. So on the top of page 2, it just goes into a little bit more about scale factor and what we just talked about down here. When k is bigger than 1, right here, when k is bigger than 1, when our scale factor is greater than 1, our image gets larger, and we call that an enlargement. When k is less than 1, when it's anywhere from 0 up to 1, that is when our images get smaller, and that is what we call a reduction. So we're looking at either an enlargement or reduction when we're talking about dilations. Okay. Last thing we want to be able to do here is to describe. The instructions for numbers 5 and 6 say describe the dilation as an enlargement or a reduction, then find the scale factor for the dilation. So they give us the original image, they give us the original figure, they give us the dilated image, and they want us to describe it and find the scale factor. So number 5, we are describing the dilation from our red shape, JKLM, to our blue shape, J prime, K prime, L prime, M prime. And right off the bat, we can see that it is an enlargement because our image is larger than our original. So that is an enlargement.
Mr. Johnson, whenever you're ready, Mr. Johnson.
Okay. And now let's find our scale factor here. So to find our scale factor, we really only have to pick one point. So I'm going to pick the point K, and actually, yeah, let's pick the point K and K prime. The coordinates for K are 4, 4. And the coordinates for K prime look to be about 6, 6. And in order to find scale factor, we need to figure out what do we multiply these two values by to get our K prime, our 6, 6. So how do we get from 4 to 6? Well, you might be able to do this in your head and say, I know if I multiply 4 by 1.5, that'll get me 6. Or if you're not sure, you can set up an equation. We know how to set up an equation. Right? 4 times what number is equal to 6? Well, 4 times what number, if we don't know the number, we use a variable, is equal to 6. And if we solve that for x, we get x is equal to 6/4, which is equal to 3/2, which is equal to 1.5. So our scale factor here is 3/2 or 1.5. Either of those will do. Okay, we're going to do a similar process here on example number 6. So we are looking to describe the dilation from the red figure WXYZ to the blue figure W prime, X prime, Y prime, and Z prime. And right off the bat, since our image is smaller than our original, we should be able to determine that that is a reduction right off the bat. And then let's go ahead and find our scale factor. So we can pick any one of the points. I just like picking the point in the first coordinate if there is one, because I think it makes life a little bit easier. So y, the coordinates for y are 2, 4, 8. So 4, 8. And the coordinates for y prime are 2, 4. So to find the scale factor, we have to figure out how we get from the coordinates of y. How do we get from 4 to 2? What do we multiply by to get from 4 to 2? Well, I know that 4 divided by 2 will give us 2. So if I am dividing my coordinates of y by 2 to get my coordinates of y prime, okay, dividing by 2 is the same as multiplying by 1/2. So k is going to equal 1/2 here. Remember, when we're working with scale factor, we are always working with multiplication. Okay, the division there is just a little bit of a shortcut to help us in our thinking. If you're not quite sure how to do that, you can always set up an equation, right? 4 times what number will give me 2? Or 4 times x equals 2. And if we solve that, you can divide by 4, and we can see that x is 2/4 or 1/2. And that makes sense that we're getting a fraction there because we did classify it as a reduction right off the bat. A couple more quick examples here. Just if we are given a scale factor, we should be able to determine whether it's going to be a reduction or an enlargement. So remember, I'll make a quick note of it up here. When k is greater than 1, that is an enlargement. That means our shape, our figure, our image is getting bigger. And when k is less than 1, so anywhere from 0 to 1, that's a reduction. So for number 7, k is equal to 3, that's going to be an enlargement. For number 8, k is equal to 1/2. 1/2 is less than 1, that's a reduction. For number 9, 0.5 is the same as 1/2, so that's a reduction. It's less than 1. Number 10, we have 3/2. Well, 3/2 is equal to 1.5. 1.5 is greater than 1, so that's an enlargement. K is equal to 0.93, and number 11, 0.93 is less than 1, so that's a reduction. And k is equal to 2.5 for number 12. That is going to be an enlargement because that is greater than 1. Okay. So when we are talking about dilations, we are either making our shape larger or smaller. When we're making it larger, that means our scale factor is greater than 1. We call that an enlargement. When our scale factor is less than 1, it's going to make our shape smaller, our figure smaller, and we call that a reduction.